So as usual, please put off your microphones unless you have questions to ask.
Nothing.
So today we start. We had done some preliminaries on this solving linear congruences. We were able to learn how to find the inverse modulo a positive number, and we did some examples. So we now want to see how to use that to solve linear congruence. So might just review a bit of what we learned last time. So basically, you know that a linear congruence is something that looks like this. We have AX is congruent to B modulo M. That's what we call a linear congruence. So usually we know B, we know M, and we know A, but we need to find X. So what we need to do here is to find. We need to find X. X is unknown, and such an equation is called a linear congruence. So this is what we want to solve. So before we saw that if I have something like A multiplied by some number, say S, and this is congruent to 1 mod M, if I have this situation. So this is just reviewing what we did last time. So if A multiplied by S is congruent to 1 mod M, then we say that S is the inverse of A, right? The inverse mod M. Modulo M, right? The inverse of A. The inverse of A modulo M. So these are the two things we want to keep in mind as we go along. So we need to understand what the inverse of A modulo M means, and we also need to understand what we mean by the definition of a linear congruence. So once that sticks, then we should be able to move on well. Okay, so when we have a linear congruence like this, and we have the inverse of A modulo M. So if this is the inverse of A modulo M, then it's easy to solve this congruence. We simply multiply both sides by the inverse. So if I have AX is congruent to B mod M, and I know the inverse of A modulo M, if that exists, and we know that the inverse will exist if the GCD of A and M is equal to 1. So if I know the inverse of A modulo M, what I simply do is multiply both sides by the inverse of A modulo M. Sorry. Pardon? Can you please keep your microphones off? I don't know why you're switching them on. When you get into the meeting, the microphone is off. So why are you switching them on? Are you trying to be a hero or something, or what is the problem? There's someone who is disturbing us. I think I'll kick you out of the. Who is this? So So if you have this linear congruence, AX is congruent to B modulo M. If we know that the inverse of A modulo M, we can multiply both sides of this by the inverse of A modulo M, and this is what we'll have. And our solution is easy. Mod M. So then this side, since A is the inverse of A modulo M, we can replace it with just 1. Because A, we know that A multiplied by its inverse, modulo M, will be congruent to 1 modulo M. So since it's congruent to 1 modulo M, I can replace it by 1. I can replace this by 1, and there's no problem, because modulo M, they are congruent. Then I'll be left with the solution on this end. AB mod M, like that. Then I'm able to find my value of X. So usually we'll try to find a value of X that is between 0 and M minus 1. It's always possible to find one value between those values. Since you're working modulo M, we need to find a value of X that is between 0 and M minus 1. But any other value outside this that is congruent to X modulo M will also be a solution. But when we are looking for a solution, usually we want to find a value that is in this range. You can find infinitely many values outside that range, but we just want to find a unique value. So are we together? It's important to get the concept first before we start solving. So that's why I'm focusing on the concept. Then we shall start solving this in the next slide. So, so we need to find the solutions to this congruence. We have 3x is congruent to 4 modulo 7. So we know 3, we know 4, we know 7. What we don't know is x. So how do we find the x? So previously, the previous example last time, we saw that -2 is the inverse of 3 modulo 7. So if you multiply both sides by -2, you have -2 times 4 on this side. So here you'll have -6x is congruent to -8 modulo 7. But we know -6 is congruent to 1 mod 7, right? You can check that. If you -6 minus, because two numbers are congruent, if their difference is divisible by, they're congruent modulo 7, if their difference is divisible by 7. And you see the difference between -6 and 1 is -7, and -7 is divisible by 7. So they are congruent. So that means I can replace this -6 with 1. And you can check also that -8 is congruent to 6 modulo 7. So I can replace 8 with 6. There'll be no problem. So that gives me x is congruent to 6 modulo 7. And that is my solution. Any other integer that is congruent to 6 modulo 7 will be a solution. Now our verification is here. If you multiply, if you make the substitution x is equal to 6, then this becomes 3 times 6, which is 18. And 18 is congruent to 4 modulo 7. And we were looking for a value of x that will satisfy this equation. So if you multiply this by 6, you get 18, and 18 will satisfy this congruence. So you have one solution, that is 6, and you can obtain all other solutions by looking for all other numbers that differ from 6 by a multiple of 7. So all these numbers will be solutions. But like I said, we usually, in this case, our M was 7. So we'll be interested in solutions that lie between 0 and 6. So unless you're asked to find a solution outside this range, then this should be the focus. And if you find one outside this range, it's always possible to reduce it to one that is inside this range. Are we together?
Yeah.
Yes, Nadirwa.
Yes, we are okay.
There's someone raising a hand. Do you have a question?
Sir.
Ask the question.
Yes. Okay, don't understand how you have replaced that negative.
There's a lot of echo from your side. I can't get what you're saying.
I'm saying I don't understand how you have replaced that negative 8 with 6.
I can't hear you, man. Can anyone get the
Hello?
question he's asking?
I don't understand how we have replaced that negative 8 with negative 6 in the first equation, the first solving.
The only thing I'm getting is I don't understand, but the rest of it, I'm not getting what you're asking. What is there anyone else who has gotten the question who can ask who has a better microphone? So the other thing is, if you're going to follow some of these classes, you need to read the previous work. If you walk in here without having read the previous work, you will automatically see stars. So you don't expect magic in these classes. You have to put in the work. There's no magic here. You basically have to read the work that you have done before so that we don't waste time on things that you should already have known. But I wish did anyone get his question? Because I need to know the question to be able to answer it. So the most important thing is you must read what we have done before and give it time. You must get your priorities right at university. You came here to learn, so put in all your time or as much time as you can in understanding these things. If you come to this class before understanding what we did previously, you will understand very little in this class. Mathematics, you cannot understand by watching. You have to do it. So there's a lot of resources you have. You already have these lecture notes. I will share the video from the previous classes. You also have a textbook I shared. For some reason, you are not reading it. So I don't know what you spend your time doing. You really need to find time for your important things. One of the important things is what you're doing in school. So maybe what I'll do, I'll just repeat the solution. Is that okay? Maybe if I repeat, it will, whatever I was asking will come out. So we'll go through this solution again. Let me just clear everything. Yeah. So this is a question. We have this congruence. 3x is congruent to 4 mod 7. I'm just rewriting it so that it is on one line. So we need a number here such that when multiplied by 3, we will get some number which is congruent to 4 modulo 7. So again, you need to remember the definition of congruence modulo 7, or in general, congruence modulo m. We defined this, and if you can't remember it, then this will not make sense. So if you are coming here hoping to automatically recall what we learned last time, it will not work. And then I cannot repeat what we learned last time every time. So the effort has to be two-way. You must put in some effort. I do what I can, but I cannot put in all the effort for you. It's not possible. So here we are, 3x, x is unknown, so we need to find x. Now, this is a simple example. You can actually just do this by trial and error, right? You could try, since you're working modulo 7, you can test this. If you check for values of x that lie between 0 and 6, if there is a solution, if it has a solution, because it may not have a solution. If it has a solution, then yes, one of these values will work. Some value for between 0 and 6 will work. So you can actually test this manually and you will find some value that works. But that only works for simple examples. So for instance, if you test with 3 times 1, you get 4. 3 times 1 is 3. And 3 minus 4 is 1 or -1, but -1 is not divisible by 7. So 1 doesn't work. 2 will not work because 6 minus 4 is not divisible by 7. And so on. Eventually, you will get to 6. 6 times 3 is 18, and 18 minus 4 is 14, which is divisible by 7. So this is a simple example. You don't even need these techniques these powerful techniques to solve this. So I hope, first of all, you've understood what we mean by looking for a solution. So that's what we are trying to solve, first of all. But now, if it is not a simple example, it can take you, for instance, if you're working modulo 200, you have too many numbers to check. So it's easier to have a technique that allows you to work easily with larger numbers. So now just before this slide, we discussed the concept of the inverse. So the inverse, if I have a number A, the inverse of A, we represent it by bar A. And this will be, if you're working modulo M, it should satisfy this property. Right? So A multiplied by its inverse will be congruent to 1 modulo M. So we're talking of the inverse modulo M. Now, in the previous class, we know that -2 is the inverse. So because if you multiply -2 by 3, yes, this is 2. This will be congruent to 1 mod M, mod 7. Okay, so this one we did last time. If you have bothered to look at the work we did last time, this should be very clear to you. So that's why I'm saying if you are going to be lazy, this thing will also treat you badly. You really must find time for this. You don't come here without revision. So we have -6. And -6 is definitely. Kitavi, put off your microphone. So -6 is congruent to 1 mod 7. And you can see this clearly because if you subtract 1 from -6, you will get to -7, which is divisible by 7. So now we know the inverse. We have the inverse of 3 modulo 7, right? So if you multiply both sides by the inverse of 3 modulo 7, then on this side you will have, this is exactly what we have done here, -2 times 3. And on the other end, you'll have -2 times 4. So when you work that out, you have -6x is congruent to -8 modulo 7. But we know that -6 is congruent to 1 modulo 7. So I can replace -6 by 1, right? I also know that -8 is congruent to 6 modulo 7. You can check that if you want to be sure. If you have -8 minus 6, this will be equal to -14, which is divisible by 7. So -8 is congruent to 6 because the difference between -8 and 6 is 14, which is divisible by 7. So that means I can replace -8 by any other integer that is congruent to it modulo 7. I pick 6 because we are mostly interested in values that are congruent to 7 lying between 0, congruent to modulo 7 lying between 0 and 6. So I can replace minus 6 with 1. I can replace minus 8 with 6. So now my equation becomes x is congruent to 6 modulo 7. And now I found the value of x that I'm looking for, 6. So you can verify if I multiply 3 times 6, I will get 18, right? And clearly 18 would be congruent to 4 modulo 7. Remember, this is what we're trying to solve. 18 is congruent to 4 modulo 7. So we have confirmed this because 18 minus 4 is 14, and 14 is divisible by 7. So 18 is congruent to 4 modulo 7. So that should answer your question, if hopefully, or even halfway answer it. You can hear me?
Yes.
Yes, thank you. I'm got it now.
Okay, but
Yes, sir.
like I said, if this is going to work for you, don't sit there waiting for miracles. You have to sit down and read these things. Sit down, do a lot of calculations, read all of them. Anything that is in the notes, make sure you can do it yourself. Okay. Hey, what is Kariuki doing? So Agustin Kariuki, I'm going to kick you out of the class now. Let's find you and kick you out. Okay, so we can now continue. So here are some exercises for you that we should be doing shortly, just to learn how to find the inverses. So the first question is to find the inverse of find the inverse of 35 modulo 3. So you need to find some number which, when multiplied by 35, will be congruent to 1 modulo 3. So that's the first one you need to do. Now, this one is easy to check because you are working modulo 3. You can just check for numbers between 0 and 2. You don't have to use any heavy machinery to solve this. Look for numbers between 0 and 2, and one of them should work. The reason it will work is because the GCD of 35 and 3 is 1, right? These numbers are relatively prime, so it's possible to find the inverse of 35 modulo 3. So the GCD is 1. This is 5, not 6. So the GCD of 35 and 3 is 1. So it's always possible to find the inverse of 35 modulo 3. The same applies to the others. The second case, you need to find the inverse of 21 modulo 5. And the third case, you need to find the inverse of 15 modulo 7. So let's see if we can solve one of them. So we know that 35 is congruent to 2 modulo 3. So if you want to find the inverse of 35 modulo 3, it should be just the same as finding the inverse of 2 modulo 3. So if you can find the inverse of 2 modulo 3, you are done. If you multiply 2 by itself, you will get 4, and 4 is congruent to 1 modulo 3. So it turns out that 2 is its own inverse modulo 3, because when multiplied by itself, it's congruent to 1 modulo 3. So 2 is its own inverse, and therefore it's also the inverse of 35 modulo 3. And it's easy to check. If you multiply 2 by 35, you will get 70, and 70 is congruent to 1 modulo 3. You can write it as a multiple of 3 plus 1. So it's congruent to 1 modulo 3. So basically, what we have done here is shown that 2 is the inverse. So anyone who is talking, I'm sending them to the waiting room. Okay, so now we can continue. Anyone who talks now, I'll send them to the waiting room. Okay, so I need to finish some of this, then we can continue. Good. So now we have done this. We have found the inverse of 35 below 3. We have shown 35 multiplied by 2. Just kick him out. I've sent him to the waiting room. He's not. Okay, I think he has gone quiet now. So 35x times 2 rather is equal to 70, right? And we know that 70 is definitely congruent to 1. Okay, so 70 is definitely congruent to 1 modulo. Mod 3. And you can check this, because if you subtract 70 minus 1, what do you get? You get 69. And 69 is divisible by 3 divided 69, right? So what I'll suggest is that you do there are these others. There are these others that are remaining, these two, finding the inverse of 21 modulo 5 and finding the inverse of 15 modulo 7. So solve these as exercises. So can you work this one out? Find the inverse of 21 modulo 5 before we proceed. The first person to get this will get airtime of 50, bundles of 50 MB. But you have to be on Safaricom.
One. Me. Kennedy. 4.
1.
2, 1.
4.
So there's a fellow called Kennedy who has identified.
21 is congruent to 6 modulo 5.
So let's try with one.
Is congruent to 6 modulo 5.
So 21 times 1
Is
equal to what?
21.
Is 21, right?
Yeah.
And if you subtract 1 from 21, what we get?
20.
We get 20.
Aye.
20
20.
is congruent to,
Oh.
I mean, 20 is divided by 5, rather. So 21, 1 is the inverse of 21 modulo 5. So who was that fellow called Kennedy? Kennedy, you make sure you remind me to send you your megabytes. Eh?
Yes.
And you are using, what is that name you are using? You need to change your name, otherwise I'll kick you out of the class. Eh? I don't want to see Technospark there. Remove that name. Eh? And anybody else who is not using their full names, please do so. I'll give you 5 minutes. If after 5 minutes you haven't done so, I will remove you from the class. So I don't want to see people with single names like this Anne, this Alan, this Bahita. Make sure you put your full names. Eh? Anybody without full names, in the next 5 minutes, I will remove you from the class. Good. What about 15? Has anyone done the one for 15, modulo 7?
1.
One. Couldn't skip the sound 1.
Okay, so I think now you have figured out what to do. Let's move on to the next step. So now we want to talk of a Chinese remainder theorem. And this example here is a typical problem that is used as for illustrating the Chinese remainder theorem. So for this one, we have the following situation. Some people who are still keeping their microphones on. Let me kick them out so that we have some peace. Is Wafula. I'll send you to the waiting room. So I think we can continue now. So the problem that we want to solve is this one. There are certain things whose number is unknown. So we know X is not known, but we know the following things about them. We know that when we divide X by 3, the remainder is 2. We know that when we divide X by 5, the remainder is 3. And we also know that when we divide X by 7, the remainder is 2. So we need to find this number that satisfies all these 3 conditions, and we want the smallest possible value that does that. So essentially, this is what we have. We say the number leaves remainder 2 when divided by 3. So here we have X is congruent to 2 modulo 3. That's by definition. Also, we say the number, the same number leaves remainder 3 when divided by 5. So it must be congruent to 3 modulo 5. And also it leaves remainder 2 when divided by 7. That means it must be congruent to 2 modulo 7. So we need to find a value of X that satisfies these 3 linear congruences. So So Mwangi again has joined the noisemakers. Any noisemaker, we send them out. Okay, so so I hope you have looked at the puzzle. This is a puzzle we need to solve. You find the value of x that satisfies all this. So we shall try to do this the hard way first. Then in the next class, we shall show you the powerful, the easier way to do this if you're working with a larger set of numbers, for instance. So first of all, we know that the integer satisfies this condition. It's congruent to 2 modulo 3. So what we do is we make a list of all the integers that are congruent to 2 modulo 3. This fellow is not learning his lesson. So we list all the integers that are congruent to. You can see all the integers that are congruent to 2 modulo 3. And how do we obtain them? Simply look for integers that differ from 2 by a multiple of 3. So you just simply look for all integers of this form, 2 plus a multiple of 3. You can easily get them by moving in increments of 3. So 2 plus 3 is 5, 5 plus 3 is 8, 8 plus 3 is 11, and so on. So keep going on in increments of 3. You'll get as many as you can. Do the same for 5. Look for all integers that are congruent to 3 modulo 5. That's the second equation. Remember, this is the second equation. We're looking for integers that are congruent to 3 modulo 5. So again, we find all of them. Here they are. We keep finding integers that differ from each other by multiples of 5. And how do you find them? Just go in increments of 5 until you have all of them. We do the same for the next one. Look for all integers that are congruent to 2 modulo 7, or at least go as far as we can. And this is this last equation. This is what we are trying to solve. Find all integers that are congruent to 2 modulo 7. So we start from 2 and keep going until we are tired. Then you stop. So now you are looking for numbers that will appear will be common to all the 3 lists that you have prepared. So the number that is common in all these 3 lists will be your solution. So you will notice that 23 appears here. It also appears here. And it also appears here. So 23 is definitely a solution. 23 is congruent to, it will satisfy these 3 equations. You can check that. 23 minus 2 will give you 21, and 21 is divisible by 3. You can check 23 minus 3 is 20, and 20 is divisible by 5. You can check 23 minus 2 is 21, and 21 is divisible by 7. So 23 satisfies all the 3 equations. Now, this method of listing all these numbers is not a very effective method. Because here we are just lucky because the common number, we're able to find it early, right? So there are cases where the common number is not this close. You may have to go hundreds of or thousands of numbers before you reach the number that is common. So before you list all those, it will take you a lot of time. So the Chinese remainder theorem gives us some techniques of solving these problems without having to list, make all these long lists. Now I think if I look at the time, it's 8:53. I think we can start with the Chinese remainder theorem next time, unless you have questions. It's Jason, you have a question, you can ask. Just put on your microphone and ask.
But I don't understand why you are. Okay, so the first list of integers.
Jason, I cannot hear. Can you type your question in the chat, maybe?
I'm asking.
Just type. Your microphone is not clear at all. Jason has gone quiet. He's not. Okay, Jason, just try again on your microphone. Maybe it will be clearer now. I need to know your question to be able to answer it. Or what you can do also, you can write it down and send it to my phone later on. I can send you the answer. Can anyone hear me? Everyone has gone quiet.
We can hear you.
Is Jason
We can hear you.
He has left.
We are getting you.
Okay, so I need some questions now.
Can you hear me, sir?
Okay, Jason, if you are not able to ask now, please write your question down and send it to me.
Like nyingine na share video yake.